Okay, so we want to set up but not evaluate the following integral from the integral for the solid obtained by rotating the region bounded by y equals cosine x and 2 minus cosine x about y equals to 4. So let's start by drawing an axis. So I'm going to draw it down here, so I'm going to need the room. So if I draw cosine, let's see, in blue, so cosine looks like this, from 0 to 2 pi, that's 1. And then if I go, if I want to draw 2 minus cosine, we'll have to go up to 2. This is going to be the midline. And this guy is going to look like cosine but flipped. Kind of like that. Okay, now here, this guy is going to be rotated about y equals to 4. So that's 2. This is 1, 2. This is supposed to be 3, the top of cosine, and then 4. Okay, so if I rotate this guy around and I do the mirror image of this guy, I'm going to get something that looks like this. And then this one's going to look like, let's just pretend like it goes up there and then it kind of goes up there. And let me kind of erase that. Okay, so let's figure out what our obviously, because it's going to rotate around this line right here and it's separated, what's going to happen is you're going to create a washer. So there's going to be a hole here. Let's draw. So here on the ends it's together, but everywhere else there's a washer. So this is kind of what it looks like. And just one more. Okay. So let's color it in a little bit. All right, well, great. So what we want to do is, as usual, our cross sections are circles, and we're going to integrate in this direction. So we're going to integrate with respect to x. And so what we want then is to figure out the formula for the radius of the inside, which I'm going to call little r, and then the radius of the outside, which we'll call big R. I'll just draw it down. So that's going to be big R. Okay, so little r, let's talk about that one for a little bit. So little r is formed by this function, the red function, 2 minus cosine x. And so the radius from here, we can look at it from the picture. Notice that from here to here is equal to a distance of 4, because that's the line y equals 4. And then you know that from here to here is equal to, that distance is changing obviously, but it's changing as 2 minus cosine of x. That's the y value. That's the distance from here to here. So if you take this away from 4, you are going to get the distance from here to here, or the distance from here to here, whichever one you want. So the small radius is simply equal to 2 plus cosine of x. Okay, and then the big radius, what we have is same kind of deal. I know that from here to here is 4, but now this time I'm going to take away the distance from here to here, which is cosine of x. And so then the big radius is 4 minus cosine of x. Okay, so then the area of my cross section, my washer, is simply equal to pi times big R, the big radius, squared, so 4 minus cosine x squared, minus little r squared, which is 2 plus cosine x squared. So then what that means is that the volume is equal to the integral. This is going to go from 0 to 2 pi of pi times 4 minus cosine x squared minus 2 plus cosine x squared. And if you actually do this, you would just get, if you do the fundamental theorem of calculus, you get 24 pi squared.